Hi, question number 5. One end of a light elastic string of natural length 4 meters and modulus of elasticity 200 newtons is attached to a fixed point A. The other end is attached to the end C of a uniform rod CD of mass 10 kilograms. One end of another light elastic string, which is identical to the first, is attached to a fixed point B, and the other end is attached to D, as shown in the diagram. The distance AB is equal to the length of the rod, AB equal to the length of the rod, and AB is horizontal. The rod is released from rest with C at A and D at B. While the strings are taut, the speed of the rod is V meters per second when the rod is at a distance of 4 plus x meters below AB. Show that V square is equal to 10 into 8 plus 2x minus x square, and for the second part, hence find the value of x when the rod is at its lowest point. Now, to tackle a question like this, we need to use some formula. First of all, there are two strings, so I need to find the elastic potential energy in the two strings. So the elastic potential energy in the two string, you're going to plus the kinetic energy because this rod is released, is traveling down x meters, and then it's going to equal the gain in, the gravitational potential energy loss, because remember the rod has gone down, so it's losing potential energy. Basically, the elastic potential energy is found by using this formula. So lambda here, the modulus is 200, modulus elasticity, so 200 x square divided by 2 times L, and L is the natural length, which is 4 meters, and because we've got two strings, okay, so we multiply by 2, that's the total elastic potential energy stored in the two strings in the system, plus the kinetic energy, which is half mv square. Half m is 10 times v square, and all of that is equal to the gravitational potential energy, which is mgh, so 10 times, then again 10 times h, and h is the length. So we set up an equation. Now we're going to solve that equation. We're going to try to simplify the equation to prove this. So 2 goes in 2 and this goes in here. 50, I've got 50x squared plus 5v squared, and that's going to give us 100 into 4 plus x. So going further, I've got 50x squared plus 5v squared is equal to 400 plus 100x. Because we're trying to show that v squared is equal to all of that, we can send 50 squared on the other side. Now I've got v squared is equal to 400 plus 100x minus 50 squared. And that is divided by 5 here, so we can put the 5 on the other side. So then what we're saying is that v squared is going to equal to 80 plus 20x minus 10x. We can simplify further by putting the 10 outside, and I'm left with 8 plus 2x minus, this should be, what is it, 50x squared, pardon me, yeah, so then minus x squared, and it has been shown, as you can see. So this is the first part of the question. Now they want us to find the value of x when the rod is at its lowest point. Okay, if the rod is at its lowest point, we are confronting v is equal to 0. The velocity is 0 now. So we're just going to have to solve this equation by equating it to 0. So 10 into 8 plus 2x minus x squared, and you would agree with me that this is basically x squared minus 2x minus 8 is equal to 0, and you can factorize by taking the factors. So we've got x, and I've got 2 times 4, minus 4 plus 2 is minus 2, and so x is going to be equal to minus 2, and this one is rejected. Alright, and therefore I've got x is equal to 4, and this is the solution. Take care.